Section 3.7. All right, our first example takes a rectangular piece of paper that will contain 30 square inches of print. The margins on the left and the right side are 1 inch, and the margins at the top and the bottom are 2 inches. Find the dimensions of the page such that the least amount of paper is used. So imagine if you're a publisher and you're trying to create pages in a book, a magazine, or something like that, and you want a certain amount of print on it, and you want certain margins, but you want to make sure you use the least amount of paper necessary. So I have drawn a sketch of a piece of paper and I have some writing on it. We have said the left and right margins are 1 inch. So we have 1 inch on each side. And we said at the top and bottom the margins are 2 inches. Alright, so I'm going to label a couple of my dimensions here. I'm going to call, going left to right, I'm going to call this distance between basically the width of the writing, I'm going to call X. And then top to bottom, the writing's distance I'm going to call Y. Which means all told, this entire side from here to here is going to be Y plus 2. And all the way across the paper is X plus 2. Actually, that's Y plus 4 because we had 2 inches on the top and 2 inches on the bottom. So Y plus 4. Top to bottom, side to side. Now we know the print is going to be 30 inches. So I'm going to describe the area of the print. That's the area of the writing. I'm going to call X times Y. And we know that's going to equal 30. That's going to be important here in a minute. Well, our whole paper is going to have area of Y plus 4 and X plus 2 multiplied. So X plus 2, Y plus 4. So my larger area here, I have two independent variables, X and Y. We want only one independent variable. I'm going to choose to replace the Y. Now that's where that other equation came in. This area, 30 equals X times Y. If I divide by X, Y equals 30 over X. Now it's only in terms of X's. Now I could take my derivative now and use product rule, but I'm going to actually distribute and simplify and then just use power rule. So if I distribute X, I get 30 plus 4X, distribute 2, 60 over X plus 8. I'm going to combine like terms and write that with a negative exponent. So 38 plus 4X plus 60 to the negative 1. That's our area. I'm now ready to take my derivative. So my derivative, I'm going to just call A prime. Derivative is 0, derivative is 4. Drop the 1 by just power rule. So 4 minus 60 x to the negative 2. I'm going to set that equal to 0 and rewrite that without the negative exponent. Okay, so now just a little algebra to solve for x. I'm going to move my negative term over. Then I'm going to multiply by x squared. Divide. So 15 equals x squared. I'm going to take my square root. Now I should get plus or minus square root of 15, but remember on our paper, we don't need a negative distance for our writing, so only the positive is going to matter here. So x equals square root of 15. I'm going to do a quick sign chart to make sure my numbers work out. So I'm going to pick a number small, or I'm going to choose 1 for simplicity. If I put a 1 in, I get a negative. If I choose a bigger number, 5, I would end up with a positive number. So that is going to be a minimum here. So when x is square root of 15, the total amount of paper used will be at a minimum. Now, I also need to know what y is. So I'm going to come back, and we said y equals 30 over x. So y will equal 30 over square root of 15. And I'm going to just leave it as an exact value instead of making the decimal. So I have these two dimensions. However, we have to be careful because those are just the dimensions for the writing. We need to know the dimensions of the page. So I need to know the dimensions here and here. And I'm going to write that down in my answer. So dimensions of and this is going to be square root of 15 plus 2. My up-down dimensions are going to be this plus 4. And those dimensions will result in the least amount of paper being used. So the last example on this page wants us to find two non-negative real numbers to add up to 66 such that the product is as large as possible. So I'm going to call my two numbers x and y. So x and y are non-negative real numbers. Okay, so my two non-negative real numbers will add to 66. So x plus y equals 66. And their product is as large as possible. So I want x times y the product, so I'm going to just say x times y equals p. We want to know when the product is the largest. Again, I have two independent variables, x and y. So I'm going to rewrite this equation so I can substitute. So I'm going to say y equals 66 minus x. And then I'm going to substitute into y. Now I could do product rule. I'm going to do a quick multiplication to make it easier for me to take my derivative. So my derivative, 66 minus 2x equals p prime. I want to know a maximum. So what do? We set it to 0. And then I'm going to move the 2x and divide. If I move the 2x over, x equals 33. So I'm going to do a quick sign chart. If I chose a smaller number, I'm going to choose 1 for simplicity. If I put 1 into my derivative, it's clearly positive. If I chose a larger number, say 40, I'm going to end up with a negative number. So that means that's going to be a maximum. Now that was our x. We also need to know y. So if y is 66 minus x, y must equal 66 minus 33, which is 33. So the product will be as large as possible when the two numbers are both 33. Alright, so that was finding a maximum value.